Hello and welcome back to Precalculus. We are now in chapter 9, talking about ellipse, hyperbola, and parabola. Today we are only going to talk about ellipse, and then we'll take care of the rest next time. So, ellipse, also known as oval, is the set of points where the distances between 2 points that we call focal points, where the sum of the distances are the same. So let me actually draw that here. No, come on, there we go. So we have an ellipse, and this ellipse is going to have two. We'll call these focal points. So we'll call them now F1 and F2, and the sum of these distances that I draw at any point you want, they're always the same. So you have, no matter where you draw and how you draw, now you can do this, they're always the same when you add these distances. So what distance? Distance L1 and L2, right? Or distance M1 and M2, distance P1 and P2. So whatever distance D1 and D2, no matter what combination of these you take, it is always going to be the same. So L1 plus L2 is going to be the same, M1 plus M2 is going to be the same, P1 plus P2 is going to be the same as D1 plus D2, right? And da. So now that gives us the definition of the ellipse, which says an ellipse is the set of all points P. Now, guys, that will be these guys. Those are points P. Of all points P in the plane, in a plane, the sum of whose distances from the two fixed points F1 and F2 is constant. So we do have in the middle point that it's called the center. Now let's take a look at this situation. So draw some kind of ellipse here and put X and Y coordinate system on it. This point here is called the center, and these two are called foci. Focus is each. So one, if you're just talking about one of these 2 points, then you call it a focus. But if you're talking about both of them plural, then you say foci. And we have these points here. It's called the vertex. and we have the major and minor axes. Major axis and minor axis. Now, major axis is always larger than the minor axis. That should be clear from the words that are used. But I found that sometimes students are confused when the ellipse is drawn this way, because now your vertices and your focal points, right, are on this vertical line. So now this is your major. So you can't learn the major is X or something. No. Major is the longer one. And then you have the minor axis. And you have your vertex. Vertex at the bottom as well. And you have your two focal points. Foci. There you go. So ellipse can be also, as you can see, vertical. And now we want to learn the equation of that, because remember, this line is made out of xy points. So there has to be some kind of formula that connects this x to a y in some sense to describe this line that goes around. And that one, right, would be, let's say, well, let's draw another ellipse. There we go. So if I draw ellipse, actually this ellipse we're going to put on the side and have copy, paste. All right. I give up. I'll draw another one. So here we have the ellipse. And what I want to do with this now is to show the equation for the ellipse. Now, this ellipse is going to go through the center 0, 0 on xy plane. And its equation is x squared over a squared plus y squared over b squared is equal to 1. So this is the equation for the ellipse, but we need to know exactly what kind of equation. This is ellipse centered at 0, 0. And it's a horizontal ellipse because we have the vertical one coming up. Now, we see A and B, and those are these lengths here, A and B. So from the center to the vertex, right, that's the vertex. And that's A, B is on the minor axis. So major axis is 2A and minor axis is 2B. Now, on the other side over here, we're going to have another ellipse that is going to be the vertical ellipse. We are going to have the same deal 0, 0, vertex on top now. Focal points are going to be on this one, doesn't matter. So now your A is again, and to be honest with you, I don't like this, but that's unfortunately the way the book has it. I like always for A to be associated with X, and then I don't have to think much about the formulas, but such is life. X squared over B squared plus Y squared over A squared is equal to 1. So this would be the vertical ellipse centered at 0, 0. And there we go. Now, there is no harm in doing what I suggested, and that is that your X value is always associated with A, because let me show you the reason why I like that better. And if you think that that makes more sense than what you have up there, you can use it. But you can use obviously what's up there, which is the way the book did this. So say I have an ellipse that is going 3, 4, let's say 4 out on these sides and 2 out these ways, right? So now you draw the ellipse the best you can, and if you tell me you're not the artist, I'm going to tell you become one, okay? So keep practicing. Don't make your ellipse look like a 2-year-old drew a rabbit or something. So this is what you have, right? It's an ellipse, and when you look at this, the equation, just by looking at the picture, equation is x squared over 16 plus y squared over 9 is equal to 1. Not 9, sorry, 4. 2 squared is 4. And now I want to draw x squared over 4 plus y squared over 16 equals 1. You see, if you associate the number, so the book technically wants you to look at which number is bigger, call that one A, but then focus that and use that number on the variable, right? So it's a little bit kind of, I don't know. I think it's backwards, but maybe it's not. Maybe I'm backwards. I really don't know. The way I like to look at this is I draw the system and I say, aha, x is going 2 left and 2 right. You see that? 2 left and 2 right. And then y goes 4 up and 4 down. And I don't care which one is A, which one is B. You know, you can just leave it any way you want. We just know that this is our answer. And that's the vertical. So the book kind of wants you to think which number is bigger from the two. And then once you figure out which number is bigger, they want you to associate that number with the variable and then I guess go that way. The way I look at things is I say, okay, this is 16 with x, put 4 on each side. This is a 4 with y, put 2 on each side, and be done. So if the question says graph, and now you have x squared over 25 plus y squared over 9 is equal to 1. All I need to do is to realize that 25 is 5 squared, 9 is 3 squared. So that means that I need to go 5 for x, because look, your x squared on top is matched with the 5 squared on the bottom. X is 5, right? So to graph this, I just realized that the bottom is 5 squared, this one is the 9 is 3 squared, and when I draw this, I make sure I go 5 left and right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 3 up and down. 1, 2, 3. 1, 2, 3. And that's it. That's bad, that's bad. Negative 5, 5. Negative 3, 3. So, there we go. Figure out what these values are, and then just go left and right. But hey, we want to move this thing around, right? We want to do the translations of an ellipse, meaning center doesn't have to be at 0, 0. We can move an ellipse up, down, left, right. And for that, we have an equation. So center is defined as h comma k. Now in our previous example, it was 0, 0, so it doesn't really bother anyone. But now, this thing is going to get shifted. And we are going to change the formula accordingly. We're going to say that x minus h squared over a squared plus y minus k squared over b squared equals 1. And the other one, right? When you have your x minus h squared over b squared plus y minus k squared over a squared equals 1, right, for the vertical. It's enough to know one, the other one is going to be the same way. Just vertical, but moves the same way. So center now is hk as this thing moves around. So find the center for x minus 3 squared over 16 plus y plus 1 squared over 36 equals to 1. So find the center. How about end graph? Because we can. End graph. Well, h and k are in the formula. So we just need to read h and k, and that's your center. So center would be at 3, because that one is with x, and then negative 1, which is with y. Please remember that your formula is x minus h. So if you have x minus 3, then h is 3. If you have x plus 4, sorry, x minus h and x plus 4, you can see that minus h equals positive 4 from where h is negative 4. So some students like to memorize it and just say, oh, always use the opposite sign. But you have to be careful with generalizations like that because they generally work on like a very small population of whatever you're looking at. And then it can be really, really bad to use in a situation where it can't be used, but it looks like it can. It's kind of scary a little bit. All right. So now I have my center, which is at 3, negative 1. And I'm going to draw that. So here's it's my y-axis. And I need my x-axis. There we go. And now we draw, or plot, whatever you want to say, 3, negative 1 center for the ellipse. Again, the way I do it is I say, x is associated with 16, which is 4 each way. Start measuring from the new center. 4 each way. 1, 2, 3, 4. 1, 2, 3, 4. We went x left and right 4 units because the function said so. Now it's time for us to go up and down 6 units because it's 36, right? 6 squared is 36. So we go again from the center, 1, 2, 3, 4, 5, 6 going up, and 1, 2, 3, 4, 5, 6 going down. Draw the ellipse, and we're done. Now, what are these points? Well, this point has the same coordinate 3, and it's 6 units up, so it's 5, right? Because, I mean, you can count 1, 2, 3, 4, 5 on the y-axis, but you can also add 6 to this one, to the y value, because you went 6 up, right? Because it's 36 in this case. And the same thing for the one on the bottom, because they're lined up on 3, but now you're subtracting 6, so that's negative 7. To go left and right. So those are vertices, and you need to be able to find, because the question can say, what is the vertex? And if you don't know, right, it's just this point. Over here to the side, I know that my y value is negative 1. That's how much I know, because it has to be on the same elevation. So that's the same here, minus 1 on the y, because the whole line is negative 1. Now, we have to find x coordinate. So 1, 2, 3, 4. 3 plus 4 is 7. 3 minus 4 is negative 1. And now you have the full graph of the ellipse with all of the vertices and so on. All right. I am going to ask you to graph one of these. Ooh. Okay, so when you run out of of standard problems, then you start, right, stuff that it's unnecessary, but we can still do it. So graph the ellipse, and I told you it's an ellipse, right? No, that's a 3 right there. 4 squared y plus 3 squared equals to 36. Did I forget? No, good. So does this follow the rules for ellipse for the equation? Does it follow or not? I'm not sure if you are understanding the question. Maybe, I don't know. Does it look like the equation for the ellipse? And the answer is no, because there are no denominators. So it would be your job to divide, and this is not one. So you have two reasons why this does not look like an ellipse equation. But if you divide everywhere by 36 to make that one that you need on the right hand side, you get x plus 4 squared plus y plus 3 squared over, this can be written as 6 squared, and then equals to 1. Now it looks like ellipse. And because it looks like an ellipse, we can quickly graph it. We know exactly how. Center is at -4, -3. XY coordinate system. -4, -3. 1, 2, 3, 4, 1, 2, 3. So this is where the center is. And if you take a look carefully, this is like having a 1 squared in the denominator. So we do go in x direction 1 unit out each way. And then we have 6 going up. 1, 2, 3, 4, 5, 6. And 6 going down. 2, 3, 4, 5, 6. It's a very skinny ellipse over here. But it's an ellipse. Good. We have two more things. Yeah, we should be able to make it. Circle is just a special ellipse. Circle is an ellipse. But this ellipse has a equal to b for the in the denominators. So if your equation for a circle or for the ellipse is x squared over a squared plus y squared over b squared is equal to 1, find the common denominator, which is a squared b squared, and then, oh no, hold on, you don't have to do it that way. You can just say if a equals to b, and let's say equal to r, then your equation turns into this. And you already have common denominators, so now add them together. And then finally multiply both sides by r squared. So on the left hand side you have x squared plus y squared, and on the right hand side you just have r squared. You see that? Ellipse, circle. So under this special condition, which is why circle is a special case of ellipse, under the condition that minor and major axes are the same, you have a circle. Can you call it an ellipse? Yeah, sure, you can call it an ellipse. But it is a circle. That's the name we gave. All right. Now, sometimes what's given to you to compute, right, could be long and painful. So we're going to take a look into this transformation where they give you, let's say, 54. Find the equation of an ellipse. For x squared plus 4y squared plus 10x minus 8y plus 13 equal to 0. Well, that's not what the ellipse equation looks like. Let's figure it out. And the way to figure this out is to do to group and then do the conversion. You'll see. The procedure isn't complete the square. There we go. So we have to do the completing the square. We have to do completing the square in this case. So let's see. For the first one, we have 10 divided by 2 squared, which is 25. For the second one, you have 8 over, it's a 2a, so that's another 8. And no, first you have to factor out the 4. I forgot about that. The only way to do that, it's not the only, but the way to do completing the square easily, right? You need to have y squared alone. See, so we have to copy this one more time and kick out a 4 over here so that we can focus on the rest of the problem. And now you do your completing the square. So we already figured out completing the square for the first one. Second one has 2 divided by 2 is 1 squared. Now, the way this is done is you add and subtract these numbers that we calculated inside the parentheses. So we have x squared plus 10x plus 25 minus 25. Because you can't just add 25 out of nowhere. You have to balance it with the negative 125. 25. Plus 4 over, and now we have y squared minus 2y. And the number we are adding is 1, subtracting is 1, plus 13 equal to 0. The first 3 are the completed square. Therefore, square root of the first, sine of the second, square root of the third, everything squared, and then you have your negative 25 out. Plus, and now we do the same thing here. We have our square root of the first, sine of the second, square root of the third, put the square on top. And now this is where the grade dies. You, for some reason, forget to multiply this minus 1 by 4. And then you end up with wrong numbers and things make no sense. So minus 4 plus 13 equal to 0. Okay, I have x plus 5 squared. And now I have minus 25, minus 29, and then plus 13. That's going to be a 16, negative 16. Okay. So that plus 4y minus 1 squared is equal to 13. Do I move it? No, no equal. Let's figure this out. So negative 25, negative 4, positive 13. So 25, 29, 16. Yeah, okay. Okay. And now we move this 16 to the other side. So that's going to be x plus 5 squared plus 4 y minus 1 squared is equal to 16. I have to divide everywhere by 16 now, because the goal is to have 1 on the right hand side. So I have to divide by 16, and then we're going to see what we get. Well, x plus 5, everything squared, divided by, well, x plus 5. That 16 is going to survive. This one is going to cancel. And this one is 1. Cool. There we go. We can graph this quickly. And we can take a look at the application of some kind. 5, negative 1 is the center. And then we go 4 left and right. 1, 2, 3, 4. 1, 2, 3.
Isn't it negative 5?
Oh my god. It's negative 5 and positive 1. Ah! Thank you. Oh, I was just testing. Yes, yes, good. Yes, I was just testing to see who's paying attention. It is, yes, HK is, it's always opposite signs. So we have this, and then we have 4 left and right, and 2 up and down. So these are our values. This looks like an egg over here. It's terrible. Okay, it's a little bit better. We don't need this point. Can I erase this? Yes, good. And if you want the full credit, you need to label all of the points. Negative 5, 1. Then remember, negative 5 is the same. And then we add 2. And then we subtract 2. And then over here, 1 is okay. Take away minus 5, minus 4 is minus 9. And over here is negative 1. So negative 1, comma 1. You have ellipse with all 5 of these present. 5 of the points, right, the vertices, and so on. So What else do we need? Well, I think we can just talk a little bit about the application. Uh, Orbits of planets, right, are on elliptical path, and the sun is in one of the focal points. So, if you consider the Earth on its path around the sun, sun would be in one of these here. So the planet will be whizzing by. It's exaggerated. It's closer to the circle than to the oval that I drew here. So yeah, I exaggerated that one. They have a lot of cool problems, guys. I hope you will look into this to get the most out of the sections. Section, actually, one section. So to recap, we have ellipse that is centered at 0, 0. Then you have the one that it's not centered at 0, 0. So we have to play the game with those H and K to find the center and go left and right and whatever we need to draw the ellipse. Any questions or concerns regarding the ellipse? No, I guess. All right. Bye, guys. See you next.